when we last met, we had analyzed the raw data for our keys. Raw data for our keys. So here's some key statistics. Key statistics. Oh, you know what? I don't know if that's visible. I have to pull it back a little bit. What were the three measures? We can't see that. The three measures that we had for the keys, the three statistics that we had collected. I'm calling them statistics and not parameters because I'm pretending this is a sample and not a population. Tell me your name again. No, don't tell me your name again. Hang on.
I even know her name.
Damn it! I have 120 of you.
There's 2 of us.
I know there's 3 of you actually.
3?
Yes.
I never.
Hang on, that's okay. It's 5 letters.
No, mine's 6.
It's 6 letters.
It's
It sounds like 5 letters because I think it ends in a Y, but yours ends in an IE, I guess.
E.
E. Nick, help me out. Give me the first letter.
K.
Or C.
Beep, beep.
Or C. Beep, beep. Just tell me.
Carly.
Carly! Crap! Beep, beep. Horn? Carly. And we've got one more. Yes, okay, all right. So, one of the statistics we got was?
Are you talking like mean?
Good, perfect, good. Any one of those, yes.
Oh, I don't remember.
That's okay. Well, I thought you.
Oh, I was saying what they were.
Oh, gotcha. So we had a mean, a median, and a mode. Mean. What is a mean of a set of data?
Yeah.
It's the average. Good. And what does that tell us? What does an average of a set of data tell us? You've got this number, right? For us, it was, I'm going to put X bar, median, and mode. Because these are the 3 names, as Carly just pointed out to us. Mean, median, mode, or average, median, mode. X bar means it's average of a what? Oh, very nice. Jolene, it's a measure of central tendency. Love that. All these are, right? These are 3, and there are many more of them. Jolene's identified these as measures of center. I want to talk more about what that means momentarily, more graphically, but that's perfect. Measures of center, yes. So, when we talk about an average, what was the average that we got yesterday for the raw? 4.7. Your name, I'm sorry. Monica, thank you. 4.7, and this was the raw. The raw data, the average was 4.7. And technically speaking, there's a unit on that too, although you don't have to, I'm not picky about the unit. It's 4.7 keys per person, good. I'm going to look for student here. That's okay with you guys. What does that mean? 4.7. Maybe you have 0.7 of a key in your pocket right now.
Not me.
Not you, not me.
It means that if they were spread evenly throughout all of the students, they would all have 4.7.
I love that, Carly. If what was spread evenly?
The keys.
Which keys?
The total keys.
Awesome, thank you. So, if we took all the keys, if I had put a bucket or this trash can, for example, next to the door and said, before you come in, drop keys in the can. And then before you left, we said, okay, we're going to do this a different way when you leave, and we're going to dump them all on the table, and we're going to split them into 30 piles. It would be the number of keys that makes all the piles the same size. So what are some of the words we use to talk about the raw average? 4.7 is the...
Common.
Good. Make sure everybody has the same common amount. I like that very much. Good. What other words do we use? Normal, that was a good one too, right? If you want to normalize, or if you will, equalize the size of the piles. Now, is that always a good thing? To do that? No, it's not. Can you think of one idea where an average will be bad? Using an average to make a decision will be bad.
Average income of the population.
Say that again.
Average income of the population.
That would be a terrible, I think, use to try to, if you're trying to make a decision based on that. And there's another, so if you use an average, why would that maybe be a bad example of, or a bad scenario where an average would be potentially misleading or tough?
Because the income,
No, go ahead.
The income of people like Bill Gates would offset the income of a large population.
So another good, and this is Veronica.
Yeah.
Veronica, go ahead.
Well, I was just going to say what she said because of the extreme.
Yes.
And the few number of people that have the extreme.
Right. So can I go a little bit further with it? It would be saying, like, suppose we took a sample, and just so happens Bill Gates got into that sample, say size 100. And they said, well, look, the average income of an American is, you know, $250,000 a year. Y'all can afford health care. I mean, there's an example. I'm saying that's a ridiculous example. I made it up right here on the spot. But using that inflated average to make a decision like that can be a good. Can anybody think of where an average would be more sensible than not using an average? I only bring this up because one of you smacked me in the face last night, which we're going to talk about after I collect some data. Where you would want to use an average to prove a point or to get an idea across.
Crickets are chirping.
Crickets are chirping. That's okay. This is a tougher question. It's a much tougher question because it's easier to find extremes than it is to find more normal. Anybody work study students? Work study students? Yeah, work study hours weekly frustrate me greatly, and it's a federal problem. So a work study student cannot work, I think it's more than 20 hours a week, is that right? Is it less than that maybe?
It might be.
Let's just make it 20, make life easy for us, because it makes the math easier. So 20 hours a week, right? They cannot work more than 20 hours a week. So let's say there's a week when a work study student, working for me, for example, has like 5 quizzes to grade or something. And they're like, sweet, how many hours? But they end up working 22. They can't get paid for that extra 2, which sucks. Not suppose that next week is late for them, and they only work 8, right? So I cry foul on that, because that student's worked 30 hours in 2 weeks, which is an average of 15 hours a week, which is under this magical number 20 that they've been laid down as you can't work more than this. So I say to hell with 20 hours per week, make it an average of 20 hours per week, at least no more than that. Because that'll absorb, if you will, those spikes that would sometimes happen. You'll analyze this, it's called a moving average. You'll analyze this more on your first out of class exam because technology is a way better way of analyzing it than doing it manually. So that's an idea where I think an average should be used, but isn't. Class size is another one. We have to wrestle to get classes added at COCC. In this room, I actually added, my last 243 was about 3-4 years ago, and I had to have 12 students in the room. That was the minimum number of students I could have in the room because somebody somewhere has decided that 12 students is the minimum number you can have to pay for my salary for that quarter of the term or whatever it is monetarily. Meanwhile, another class I had that term had 70 enrolled in it, which was 35 over the limit of 35, right? So I said, now if I got 12 here and 70 here, that's 82 divided by 2 is 41. I got an average of 41 students per class. They said, it doesn't work that way. I'm like, why doesn't it? A student paying tuition in that class is equivalent to the student paying tuition in this class, yeah? So what's the difference? Oh, thank you. So what's the difference? The answer? There is none. It's money going into the school. But the artificial limit of there have to be 12 students in a room reigns supreme. Why? I don't know. This is why I get louder in return. Hopefully eventually somebody will hear my logic and hear that it's sound and be like, oh, Rule's got a point. But, you know, it's been 10 years. I'm like Andy Dufresne in prison writing letters. You know, eventually they're going to, you know, then I'll start writing 2. So, anyway. Good! We got an average. Beautiful, beautiful. What was our median?
Median was 4.
Was it 4?
Yeah.
Good! And what good? And then so Nick gives us a median of 4. Monica says, what is the median?
Middle number.
Good. After we've done what?
Taking away the same on equals.
Good. We've lined them all up. We've lined up all the numbers and taken away the same number on the left and the same number on the right. The middle number, or the middle of the middle 2 numbers,
Right.
is the median. Good. I think that happened to us, I believe.
Doesn't it matter if they're in order?
It does, totally. It have to be in order, Nick.
Okay.
They have to be ordered before finding the median. Otherwise, you're finding some data point that's pseudo-random. Your median is 7, maybe, but not unless they're in order. Why? How is the median different than the average? Give me one way. In your own words, perhaps. Please.
Excluding the highest and the lowest.
Oh, good. In what? Give me more. I love that.
Well, without the highest extreme and the lowest extreme, then you're getting a more normal sense of the average.
So, I like this very much. So, if we have extreme values, and I know this word extreme, we keep using this word extreme, and some of you are like, okay, what makes it extreme? What makes the biggest data value an extremely big data value versus just the biggest? Because clearly, for example, in this room there is a tallest person, yeah? Are they freakishly tall? Or just, not to pick on the tallest person in the room. Or are you just the tallest person? You see what I'm getting at there? They might not be unusually large. We have ways of measuring this, which we'll get into as the class goes on. So, but the median does a good job if there are unusually large or small, getting rid of these extremes and getting a truer look at center. That's good, Marty. I like that very much. Thank you, thank you. So, the median, it sounds like, doesn't care about how big the data points are. It just cares about how they're arranged, smallest to largest. So if the biggest one is 100 or 1,000 or 10,000 or 100,000, Bill Gates' salary wouldn't count any more than the lowest salary in that. It would just get tossed off with the lowest. Good, very, very good. And do we have a mode? You had 5. The other class was amazed by that, by the way. Let me see how good my memory is. 1, 2, 4, 5, and 8?
Yep.
I remember the 1, 2, 4, and 8. That's what I guessed the last one. There wasn't a power 2. Good! And the modes are?
Most occurred.
Right, the ones that show up the most, it just so happens you had 5 data points that each showed up 4 times. Tell me your name.
Claire?
Claire, go!
Okay, so when you say mode on an exam,
Yes.
we'd list all 5, we wouldn't just say a mode of...
Correct. All of those are modes.
Okay.
All of those are modes. Now, it gets more realistic as your data sets get bigger.
Okay.
Because that probably won't happen. If I took a sample again and added like 10 more people into the group, I guarantee we wouldn't have a mode of 8 anymore. That was just a freakish random occurrence.
Yeah.
Much the same way my son sunk my submarine in his first 3 shots at Battleship last night. Booger. He's like, I'm good at this. I'm like, you're lucky at this. Because he's 6. What does he know? Does a lot, actually. So yes, I don't think those modes would stand much
Okay.
longer after 30 or 32 data points for everyone. That's fantastic. Awesome, awesome. I'm going to slide this up. Let's see if I can break it over. Oh, that's perfect. That's absolutely perfect. And I think we started last time talking about, can we pull these measures off of this graph? Okay, so that's the idea. Raw data is phenomenal if you can get it. But if we can't get the raw data, can we still do meaningful statistics in a grouped situation? So that's what I want to look at.